Welcome back. In this video, we'll explore complex numbers in Python as essential topic in engineering, data science, and physics. Python makes it super easy to work with complex numbers because it has native support built right into the language. So, what are complex numbers? A complex number has two parts, a real part and an imaginary part. It's written in the form of a plus bj. We must have studied this in our maths earlier in school. A is the real component and B is the imaginary component. For example, 3 plus 4j means the real part of 3 and imaginary part of 4. This format is widely used in mathematics, physics, and signaling processes. Creating the complex numbers. You can create complex numbers in two main ways in Python. Simply type x is equal to 3 plus 4j or y is equal to complex 2, 5. Both create valid complex numbers. So when we are typing let y is equal to complex 2 plus 2 comma 5, it is going to give us 2 plus 5j. Python internally stores and handles this efficiently. No external module is required. Accessing the real and imaginary parts. So you can access individual parts easily. So once you have complex numbers, you can easily extract its part. For example, x is equal to 3 plus 4j. So once we say print x dot real, it's going to give us an answer as 3, output as 3, and x is equal to image imag, it's going to give us an answer as 4. Complex arithmetic. Python allows you to perform arithmetic operations directly with complex numbers, additional, subtraction, with subtraction, multiplication, and division all work the same way. Complex conjugate. The conjugate of a complex number flips the signs of its imaginary parts. So what does this mean? So here we have like x is equal to 3 plus 4j. So when we say print x conjugate, so it's going to flip it to negative. This is useful in many operations like dividing complex numbers, simple expressions in engineering. Magnitude and phase. Sometimes you want to find the magnitude or phase of a complex numbers, especially in physics or electrical engineering. So you can do using the cmath module. So we just have to import the cmath and write x is equal to 3 plus 4j and print EPSX. It's called a magnitude. It's going to give us phi as a magnitude, and print cmath dot phase is going to 0.927 as in radians. The magnitude represents the vector length and the phase gives us angle on the complex plane. Polar and rectangular conversions. You can easily switch between polar form and rectangular form using cmath functions. So where are these used? So complex numbers have countless real-world applications. They're heavily used in electrical engineering for AC analysis, signal processing for wave transformations, control system for stability analysis, and scientific simulation that involve complex equations. So key takeaways are, let's summarize. Complex numbers are represented as a plus bj. You can easily access the real and imaginary parts. Use the cmath module for advanced math like magnitude and phase. Complex numbers are essential in scientific, mathematical, and engineering applications. Thanks for watching this video.